everybody. Today is going to be a short stream because I had a lot of technical problems before. My internet connection cut out and wasn't stable for a few hours, and then also OBS decided to suddenly don't recognize any capture devices anymore, or well, didn't show any image for them. But finally it seems like everything is working. And as promised, I'm going to tear down this little USB switch and see how the hardware compares to the one where Scanlime did a mod for, so that it had a 4-button remote control that was hooked up via audio cable and tucoplexing. Without further ado, I think we should get started. One thing I already found out earlier today is that in this hardware revision they fixed the bouncing, so it worked quite well. I can quickly hook it up so that I can show you that before I take it apart. Let's get some USB going here. Okay, wow, so as you can see, of course it can show you without hooking up multiple devices, otherwise it won't switch because of the voltage detection on the USB ports. Okay, yeah, it also has the feature where it like switches automatically to the last device that was connected. That's a thing that I personally don't like, so we can see how we can modify the firmware to disable that. Could be easy or hard depending on what we find inside. So yeah, as you see, they fixed the bouncing of the button. It now works flawlessly. But we want to look inside and not about the debouncing. Oh, and for those who are watching, on the left side of the image you see a chat window. That's Twitch. I will also try to keep a look on YouTube chat, but that's not going to end up in the video. And hi, Micah. Yeah. Okay. So much for that. Let's take this apart. I guess it's quite similar to the other devices, and it's just under the buttons some screws. Oh, actually, no. It's not under the feet. There are no screws under the feet. So, oh no, did they? Oh gosh. Yeah, it almost looks like they glued the thing together or used ultrasonic welding. No, here it comes apart. Let's see if we can. Maybe it's just clipped. It's definitely does not want to come apart. I think we can still carefully pry our way in there. Let's see. It's a very tight fit. Let's see what I have an additional tools to get this apart. I'm not really happy yet with the camera setup for close-up stuff, but currently that's the only way I can do it. Okay, it's really doesn't want to get open. Oops. I haven't quite figured out yet how actually they hold the case together. Oh, here's a clip. So let's see, can we get that? Yes. That's one side. Ha, here we go. Yeah, so that's the inside. It looks quite familiar actually. Let's screw this PCB out of its case. Yeah. Where do I have that? Okay. Let's come here, screw. Okay. Okay. So, they don't any longer use 3mm LEDs. They have just some 4 surface-mounted LEDs on the bottom, and other than that, let's take a look at it with the scope on the ICs there. Whoops, that was the wrong button. So, what do we got here? It again looks like it's a binary tree with 3 two-way switches. Let's see if we can read those. Yeah, here we go. So those are 70/30. Are those? I can't remember what the ICs were labeled like on the switch Micah took apart. I see Micah is in the chat. Do you remember what the ICs were, the USB switches? Anyway, they again look like some generic 2-port USB switches, but we can take a closer look afterwards. Let's look at what looks like to be the microcontroller. I actually haven't heard about this brand. Oh yeah, Mika just messaged in YouTube chat that it are the same switch ICs, USB switch ICs as on her model of the thing. So I'm going to try and find a datasheet for what looks like the microcontroller that's controlling everything. Yeah, so that looks like the hi there, no problem, that's fine. Mika, anyway, that's the microcontroller they use in that hardware version, so it's not any longer STM8. It's some other brand, and let's take a look at it. Oh, it's the same STM8. Okay, then I was just confused and my memory is bad. Well, okay, then I just pull up. Okay, then let me check. If it's the same STM8, that's a good thing. So yeah, Mika just said that the data sheets are both linked in her Git repo. Let's pull it up for a sec. Yeah. That's the USB switching I see. Yeah, and let's open also the other thing. Yeah, open it. Anyway, so I'm confused. You mean, you said it's the same same STM8, so basically that Novoton and N76E003, it's just a like knockoff version of the STM8. Yeah. I'm yeah, that's what I thought too. That's not the same microcontroller. Yeah, it's it's also an 8-bit microcontroller, but it's an 8051. So yeah. But it's now take a closer look. Oh yeah, I go back to the scope and then you just take a closer look at the microcontroller and actually also on there are a few headers that look interesting. Also, funny enough, the new hardware version also has a not placed IR receiver, as it looks like. So apparently they carried that on to the new version and again did not populate it. Yeah. So for whatever reason they did that. I would be really interesting to find out if they like sell that switch or something like under a different brand or something with IR. But yeah, the other thing here that looks quite like a debug header is this thing here, and I wanted to follow the traces. So I definitely looks like, yeah, they're both connected to the microcontroller, and let's see, where we have a pin out in this data sheet. Oh, here we have one. So from the looks of it, that must be pin 1, 2, 3, pin 4, pin 4 and 8, and if we look on the datasheet again, pin 4 is reset. That's the one that's directly connected, and pin 8 is has various functions. We have to look that up. I'm not totally not familiar with those types of microcontrollers, so but it's a transmit port of the serial interface, as it looks like, of the UART, so could be a big clue that that's actually the debugging interface and programming interface for that microcontroller. So let's see, if we go by that, pin 18, which is this pin over here, is the receive port of the UART, and it looks like I have to take a look at the bottom of it. Let's see, here we have the debugging port again, and there's one trace on the bottom side of the PCB, And if we trace that, that ends up at a wire that's most likely under the microcontroller. So guess just take the multimeter and test it and see where it's connected. So yeah, let's try that. Take a closer look again under the scope for a second. Yeah, so basically we want to find out what this pin here does. So if we go, whoops, back over here, we can just measure that. Oh, wait a second. Yeah, that's connected to pin 18 of the microcontroller, so chances are high that that's just a serial interface, but let's take a closer look again at the data sheet and find that out. So yeah, basically we have discovered that the debug interface is connected to reset, to this pin here, and to this pin over here. So let's see. Does it have a... Wow, nice. Okay, let's see. I/O ports, watchdog timer, serial port, SPI, I2C, PWM, ADC, interrupts, in-application programming. That looks like something that could interest us. Okay. Yeah, let's just the registers, and the programming can be protected. Oh yeah, you're right. Yeah, there's an... Oh yeah, in application programming, yeah, you're... Yeah, totally. I didn't think about that. Thanks for the hint. There's this short part about ISP, but yeah, it's just a demo code for in-circuit programming. Let's see where this link takes us. Looks like apparently to a blank page. So... Oh no, I'm just... Why the hell did that thing... I thought it deinstalled it. Okay. Now let's take a look again. Okay. One sec, I have to wipe this add-on that I already pretty sure I'm already just have uninstalled it, but for some reason it's here again. So let's try this site again. Okay, that wasn't actually the case. The website is just completely broken. Oh, hi. Is it my browser or is the website really broken? Okay, it's my browser, so yay, fun. Let's see if it works after we open it again. What the heck? Oh, now it works. Yay, let's see if we can... Oh, let's try the link again in the PDF. Maybe it works now. No, sadly that link in the datasheet still doesn't work. Why the hell did it change to German? Development boards, ID. They do have a programmer too. Let's quickly look at that one. What's with that site? According to the language selector, they don't even have a German version, yet it always jumps to German. That's annoying. Let's see, product related information. Yay. No, I don't want to contact the salesperson. Let's see what the search function has for us. Resources. Gosh. Have a driver for Kyle and for IRR workbench. There's a data sheet again. Nice ICP programming tool, ISP programming tool. There's a user manual for the software development kit. Let's look at that. Oh, their SDK is actually a piece of hardware. Okay. Well, interesting naming. Still not really the thing we want. Third-party tools. That's most likely just their program. Again, it jumped. No, that's just a programmer tool. Let's see. Let's just search for in-circuit programming. Let's see what we have here. Actually, it seems like, yeah, the in-system programming is actually done over a bootloader. It's just, it seems like it by reading all over what is here, because yeah, here's a FAQ that reads how to write the ISP into Nuvoton 8051 MCU series, and they say that the board support package for the 8051 the board support package of the 8051 ICP programmer contains a standard ISP program. So it looks like that is just again a thing that's completely implemented in software. So we have no clue if they use that. On the board. read a bit through this documentation on the site. What's again the part number N76? Oh, let's check again before I say something that it's not correct. So yeah, it's the N76E003 AT20. So it looks like the microcontroller on the switcher is not listed on that page, so let's look a bit further. Let's see what's written here. Oh, hi, people in YouTube chat. I lost a bit track of chat. Yeah, that's Shofli. Yeah, that's related. It's a newer hardware version, and we're trying to figure out how it's currently trying to figure out how the microcontroller is programmed. They used it's a Nuvo Ton 8-bit 8051. Yeah. For everybody that translated the chat that's showing in the video is Twitch. Yeah. So I'm still not entirely sure how the programming, like the actually not software assisted programming on this microcontrollers work. Let's see, okay, they call it an ICP. Let's look up what the site says for ICP. Oh. That looks interesting. Okay, yeah, they have a serial wire debug interface, and their new link is the programming tool for that. Let's see if there's some information on the net. About that particular programmer. Especially if... Oh! That looks interesting. Apparently people have... looks like people have flashed it with the ST-Link. But yeah, that's completely different microcontrollers that are mentioned here. Yeah, that's the ARM cores. This Nuvoton also sells. Oh, it's interesting. Oh, it's again an ARM. Let's just look. Yeah, but it's... let's keep that open. Could lead to something, but it really looks like they really want you to buy their New-Link programming tool. That's again just... yeah, it's just again their New-Link page. I didn't expect it to the stream to that quickly turn to just like googling docs about I don't know, I never heard about that company, so I would call them a strange microcontroller manufacturer that apparently really wants, with what I've read about other microcontrollers and people having to reverse engineer like simple things like erasing, how they erase the chip. It doesn't look that good. So I might move that searching of the specs for how their programming interface works for later, and like after the stream, and maybe just for now take a bit of a more look around at PCB itself. And then I will dig through the web and try to find out how the hell the programming works. Currently, I don't find much about it. Are the people watching interested in anything particular or have any ideas how to proceed, or do you want to see something about the board? So as I mentioned, before they replaced the 3mm LEDs with just regular surface mount LEDs that are on the back side. They didn't even bother to put in any light pipes or something. It's just like the case has some basically cylinders pointing down. That's, I think, yeah, it looks like they just line up with the PCB, so that's just like tiny holes on the upside where the light shines through. They have just a regular push button here. And other than that, the PCB is not that exciting. They have just, again, 4 diodes for the 4 connectors, and interesting enough, they also have a footprint here for... Oh wait, is this just another... maybe we can see it closer over here. Oh, yeah, that's just to, for what looks like... let's get some light over here, maybe we can see it. Oh no, actually, it's not just another different footprint for a different footprint diode. It's actually really looks like something with more intelligence. It's with the two resistors connected to it, which seems like those are footprints for MOSFETs, but what do they want to do with that, actually? So the thick trace is just the 5 volts coming from the USB. Yeah, that makes sense that they just used the MOSFET for like an ideal diode. Yeah. But I think if you have multiple... The thing is, if I remember correctly, the circuit for using a MOSFET for that is you need like more than the circuit for using it for reverse polarity protection, because it would connect all the 5 volt inputs together as if just one of them powers it up, the circuit, there you have the voltage drop, and across the gate. Because like I've seen circuits that do that, but they have like they use for control, they use a matched pair of bipolar transistors that are hooked up to the gate that basically compare the two sides of the they basically compare drain and source of the MOSFET, and because they are a matched pair, you can like dial it in really tinily, so that if there's just the slightest bit of a difference in the one direction, it turns off the gate. That's the circuit I have seen for that. But yeah, it's a good guess that it's just for having a lower voltage drop. So yeah, somewhere we should have the again the sense connection that they use for sensing the connected devices. See if with one of those it's maybe, yeah, here we have one where it's looks quite visible. So yeah, R25 is, yeah, R24 and R25 just voltage drop across those two resistors, a voltage divider, and I guess if we follow the trace that goes starts at R25, we will end up some GPIO pin of the microcontroller. So I will just do that. Let's see if I can get both of it into the view so you can see what I'm doing. No, sadly not. So yeah, R25. Yeah, that's actually just pin 1 of the it's just pin 1. Bye, Katja. Sleep well. Yeah, so pin 1, let's open the data sheet again of the microcontroller. Where do we have the... Oh, what the hell? Where do we have the pin out again? Here we have pin 1. Yeah, that's just regular GPIO pin. I'm pretty sure if we look again at the PCB, we find like a similar voltage divider on all of them. Yeah, R26 and R27 seem to be it again. And actually it's now start taking some notes for the GPIO pins. because the voltage the voltage detection inputs are something that can be used for hacking a remote into it, because I don't really care about that feature at all. Mostly I think it would be actually just annoying. So, so we found out that port 3 is hooked up we found out that the voltage sensing for input 3, or well, downstream port 3, actually it's upstream. Well, anyway, so USB 3 is pin 1 on the microcontroller. Let's see let's find the other ones. So yeah, let's measure from here. Well, that's a surprise. I could have bet that that's the sensing voltage divider for port 4. Oh wait. Yeah. Here we go. That's pin 10. So so USB 4 is pin 10 on the MCU. Yeah, it looks like it. As Micah just said, that she thinks that the Nuvoton chips are a direct competitor to the STM8s, and with the one-time programmable bootloader, without knowing what's on there, it's pretty much a lot of guesswork to get anything on it. I mean, if I read the documentation correctly, there's still that what did they call it? Yeah, their ICP interface, their in circuit programming. That looks like it's hardware. Just quickly jump back to that. So yeah, if I read that correctly, it's through the serial wire debug port of the microcontroller, but you need their proprietary New Link programmer. I couldn't find anything besides this one JIT repo that talks about some form of hacking the SVD of Nuvoton, because it's apparently not standard. Like, it's not a SVD interface as in other systems from other vendors. So yeah, but I will look into that after the stream and like spend a couple of hours hunting the web for it. So yeah, but let's check the rest of the GPIOs. I mean, so one could still build a remote with that, even it's not like as neat as hacking the firmware. At least you can hack the hardware and quote abuse the voltage detection inputs for just like 4 buttons. Let's see where the voltage dividers for input 2 are. So that's input 2. Yeah, it looks like the trace for the 5-volt input is on the bottom side of the PCB. And let's see. Interesting. That's okay. That one trace with the resistor in it, R4, that seems to just be the trace that's going to the LED. But yeah. R13 and R23 look like good candidates for the voltage divider. Let's check the values. Yeah, it's the same. So we have a 10K and a 34K resistor. If my brain doesn't play tricks on me. So from here to somewhere, one, two. So that's pin 16. So pin 16 is USB 2. I started writing that down in a strange way. Let's see if we can clear that up a bit. So USB. So yeah, USB 3, USB 4. So those we already found out. So 1, 2, and yeah, USB 2 is connected to pin 16 of the microcontroller, and that leaves only USB 1, and here again is our voltage drop, and let's see. That's easy. That's pin 15. So, yeah. So we found the 4 voltage sensing inputs. Let's take a look at the USB switches, and if they again hooked up the enables of the switches to the microcontroller and additionally grounded them. Pulling up the datasheet again. Output enable is pin 9 of the ICs. So looking at the two oh yeah, you can clearly see it very good in that shot. Like for that particular switch, they have just a 0 ohm resistor connected to ground, but I'm not sure if there might be a via under the resistor. No, there's no trace underneath there. So that leaves that. Let's look at this one. Oh, interesting. So here we have again a 0 ohm resistor that pulls the output enable of that switch to the ground plane, but here we also again have a trace that's connected to the microcontroller and is hooked up to yeah, it's hooked up to pin 20. And actually I've just discovered that I fucked up the pin numbers for the voltage sensing inputs because I somehow flipped the IC in 180 degrees in my head. So let's take a quick look at that again. Whoops. So what I thought that's pin 15, it's actually, yeah, is actually pin 5. Yeah, what I thought was pin 15 is pin 5, and the other one is, okay, that's pin 5, and the other one is pin 6. so that leaves that too, and USB 3 is correct, and USB 4 I have to check because I'm not sure if I flipped the IC in my head then or not. So according to my notes, it's pin 10. Yeah, and that's correct. Okay, so only 2 were mistaken. Yeah, but yeah, so again we have the same thing that they did on the older hardware version, where they hooked up the output enables of the switches, at least for that one switch, to the microcontroller, but also grounded it with a 0 ohm jumper. So that's interesting. Let's look how it's on this other switch over here. So yeah, we have pin 9. Yeah, and pin 9 is just grounded with a 0 ohm jumper, but it's not connected otherwise. Let's triple check that if I've overlooked something, but it sure looks like there's so currently we can't have a connection because it should have at least made a noise once, because that's after all connected to ground. Yeah, no wonder that's the pin that's connected to the output enable pin that's grounded. Interesting. What's pin 3 according to the datasheet? That's a surprise. Why is pin 3 grounded? Let's see. So pin 3 is connected to this via, but also to this cap. Can we get some? Not sure. But yeah, not 100% sure where this one goes to. It could be one of these 2 traces. Let's see again. could take some high-res pictures of both sides and then overlap them in Photoshop and try to stitch at least the top and bottom layer together, but that's that should be, it has to be a 4-layer board, otherwise they, at least a 4-layer board, otherwise they couldn't just not with. If you look at the track widths of the differential microstrips of the USBs, they never could impedance match that with 2-layer PCB. You need at least a 4-layer PCB, otherwise it's not doable. You get trace widths that are just too big if you want to get to the impedance you need for USB. So yeah. That's still like bit of a mystery why pin 3 of the controller is grounded. Because if it was just like some parasitic capacitance, or like just a capacitor that needed to be charged and it's not really grounded, it took long. Like that would have happened after a short amount of time, and then we would have not continued to measure short circuit between ground and pin 3. But it's also not clear where the via goes. That's right after the pin. So wait a second, we know that I think I can find it out, because we know that pin 1 is connected to one of the voltage sensing ports. So if we follow that trace, it just goes to there. Oh, pin 3 could be the button. What? A normally closed one? That would be quite interesting. Let's measure that again. Yeah, let's get some ground here. Oh yeah, I fucked up. I was putting so much pressure on the probes of the multimeter that actually, because now the PCB is resting on the button, and by pushing down, I pushed down just hard enough, which is not much because it's just a micro switch, a small one, that I clicked the button. So yeah, that's why we like only on the third or fourth swipe over the microcontroller had a short circuit. So yeah, we just found the button, like that button over here on the bottom. That's the switch for switching the channels. So yeah, it turns out that pin 3 is connected to the button. So I think I actually might wrap that us up here, because I'm kind of out of ideas what to do next. I will crawl through the web and see if I can find some more information about how to program these microcontrollers, but I don't know if that's going to be more successful or not. I hope so, but it kind of looks like they require you to buy their programming tool, and I don't know, maybe if it's like 10 to 15 bucks or something like that, I maybe could buy it, but that leaves us with, like, as it looks like, the only tools you can program this with, or like the compile, is they offer you like a plugin for Kyle and IR Workbench. Yeah, I will just leave it open and see what I find, and then come back to it in the next stream and see what I've found out in the meantime about programming that particular microcontroller, and see if there's some information out there about their programming tool. And yeah, that's currently what I've planned to do. Well, I hope you all enjoyed the stream, and I want to do a couple more things this week. I want to mod my 3D printer, and I have like, I can show it to you quickly, like so I 3D printed a nice little case for it. That's this here. That goes mounts on the side of it. There's already inside is the Raspberry Pi. That's already hooked up to the printer, and there's space for the original electronics, that main PCB for the printer, and here's just a relay board. I haven't really made up my mind yet what I'm going to do with it. I'm thinking about letting it control the power supply of the printer itself, because the Raspberry Pi is running anyway off a secondary 5-volt supply, so that Octoprint, which is running on the Pi, can switch off the printer like completely. And there's a second part in the second case that matches the first one. I couldn't print any bigger than that. That's like, that thing barely fit in the build plate. There's a second case that just goes like, connects like here, and then it's just the whole side up of one printer, like the side of the printer. And those are just like 2 MOSFET boards. I don't know, like, they don't really use particularly good MOSFETs for these boards. Like, I pulled up the datasheet, which was a bit of a tricky to find because it's from generic Chinese MOSFETs, but like, they could have used some modern MOSFETs that like have a ultra low on resistance, and then they won't need that big heatsink for, like, what does the heater have? The heater has 40 watts at 12 volts, so that's not even 4 amps. And with modern MOSFETs you can switch that without a heatsink. If you like take a MOSFET with an on resistance of a couple of milliohms, like take a MOSFET with like 5 or 10 or 20 milliohms on resistance. If you, at 4 amps and 20 milliohms. You still only have, what do we get? We have 4 amps, 20 milliohms, we have 80 microvolts, and 4 amps times 80 microvolts. We have yeah, they have to dissipate 320 milliwatts. Like, yeah, and I don't know. But well, I have got those MOSFET boards, so I might as well use them, even though engineering-wise they're, well, quite old tech. But hey, oh wait, just catching up on chat. Oh yeah, they have like, I haven't found the download yet, but they listed on their site. Let's just go back quickly into that. Like they listed that the SVW interface, which looked like it's completely built in hardware. So if we can find a way to talk their flavor of SVW with the chip, we should be able to get onto it. But what I've catched in the datasheet, you of course can disable that via register, that you can read out the flash memory. So, but if they, as in the other hardware version, didn't do that, we could be in luck. But it looks like, from quickly searching, that they have nowhere documented how that interface works actually, and they just want you to buy their new link programming tool. But yeah, maybe I will search if I find somewhere like the tools they have listed here, the ICP programming tool, where you see a screenshot here. Yeah, also Micah said she found some dev boards that use the chip. Maybe there are some downloads for that. Yeah, that's a good thing. Yeah, anyway, I was about to wrap up the stream. Thanks for watching. I hope you enjoyed, and see you all next time. Bye.